You're listening to the N2K Space Network.
What's better than building the next generation of communication satellites? Building it with a couple of your close friends, of course. And a consortium of European companies has formed to do just that. And they'll be jointly bidding on Europe's next-generation multi-orbital constellation of communication satellites called the IRIS2.
T-minus 20 seconds to LOS speed rest. Go for deploy.
Today is May 3rd, 2023. I'm Maria Varmazis, and this is T-minus. Teaming up to bid on IRIS2. Link 16 to link up to space. Tuberville asks Space Command, are we there yet? And a conversation with T-minus producer Alice Carruth all about the Spaceport America Cup and why this event is something you should know about. It's very near and dear to her heart, so definitely don't miss it. Stay with us. And here is today's Intel briefing. It's not just a good idea, it's good business. Airbus Defence and Space, Eutelsat, Hispasat, SES, and Thales Alenia Space are all bidding, all together, on the IRIS2 constellation, which is also known as the European Commission's Infrastructure for Resilience, Interconnectivity, and Security by Satellite. The IRIS2 is a communication satellite constellation which is meant to boost European government and business access to satellite-based internet broadband. And in the EU's own words, it's a new space-based pillar for a digital, resilient, and safer Europe, and will foster European competitiveness and societal progress. And the EU's official page for the program wants this constellation to be both low latency and high security. Secure by design is a key phrase that comes up a lot on the page, with this new system having what they're calling enhanced cybersecurity as well as quantum cryptography. In fact, the IRIS2 is the keystone project for a critical infrastructure quantum cryptography initiative called the European Quantum Communication Infrastructure, or EuroQCI. Looking at the big picture, the IRIS2 would be dedicated to European use for border surveillance, crisis management, and secure communications for embassies and the like. It's also meant to help bridge the digital divide, so to speak, getting more remote areas of the continent online. To help future-proof scalability issues, IRIS2 will also be multi-orbital, meaning there would be satellites in low Earth, medium Earth, and geosynchronous orbits, all to form this constellation. ESA is spearheading the effort on the IRIS2 satellite constellation, and ultimately they'll be deciding on the winning bid. And we'll find out who gets the IRIS2 contract in early 2024. And whoever gets it, the plan, says ESA, is that the new constellation should be in place by 2027. Link 16 is getting a bit of an upgrade thanks to a new cubesat headed to low Earth orbit, or LEO, in June. Okay, so what's Link 16? It's a secure, jam-resistant tactical data link network used by NATO countries and their allies, essentially used to connect just about everything to everything else: ships, aircraft, ground forces, all in real time with high-speed data sharing. It plays a crucial role in enhancing situational awareness, joint and coalition forces interoperability, and ensuring secure communication during military operations. Until recently, the space segment has not been integrated into the Link 16 network. But that changed in early April this year with the launch of the SDA's Tranche 0 of the Proliferated Warfighter Space Architecture. This new Link 16 satellite, made for the U.S. Air Force Research Laboratory, is simply called XVI, or 16 if you're a smidge rusty on your Latin numerals. XVI was made by Viasat and uses a Blue Canyon 12U CubeSat bus and a Redwire L-band antenna. And it's due to head to orbit via a Transporter 8 rideshare. NASA is working with the Department of Energy to ensure that the agency has access to sufficient plutonium-238 for future missions. The isotope is used to produce electrical power and radioisotope heating units to keep spacecraft warm. NASA's program executive for radioisotope power systems, Len Dudzinski, says that the DOE are more than halfway to a constant rate production goal of 1.5 kilograms of the isotope a year, and they expect to reach that goal in 2026. Indecisiveness has no place in sports or in politics, according to former college football coach of the year turned U.S. Senator Tommy Tuberville. At a Senate Armed Services Committee hearing, Tuberville aired his feelings of frustration over the U.S. Space Command's drawn-out decision on a permanent home. Tuberville urged Air Force Secretary Frank Kendall, who's been tasked by President Joe Biden to make the final decision on Space Command's home, to make up his darn mind. It seems that although the Air Force declared Huntsville's Redstone Arsenal its preferred location nearly 2 years ago, the draw of Colorado is still strong. All's fair in sports and politics, right? News from overseas now, and newly amended recruitment guidelines in China took effect on May 1st. The Chinese government has reportedly changed conscription laws to be ready for high-tech warfare, to include space and cyber conflict. The People's Liberation Army's new guidelines state that conscription should focus on preparations for war and on recruiting highly skilled personnel, including former soldiers. Some financial news now, and competing teams led by Lockheed Martin and Raytheon have both been awarded $30 million contracts by the U.S. Space Force. The groups are contracted to develop ground systems for the ESS, or the Evolved Strategic SATCOM program, that could sustain a nuclear attack. ESS is a hybrid space program run by the Department of Defense to provide satellite communications capability for the nuclear command, control, and communications mission across all operational environments. The Pentagon expects to spend $6.5 billion on the ESS program over the next 5 years. Now, staying with Space Force contracts, and Axient has been awarded a $94.5 million 5-year contract to deliver engineering and technical support to Space Force's Space Systems Command, also known as the SSC. The California-based company will deliver services to the Space Systems Integration Office of the SSC under the STS-3 task order. And Loft Federal, the government subsidiary of Loft Orbital, has ordered Mynaric laser terminals for its work on the Space Development Agency's National Defense Space Architecture Experimental Testbed, known as NEXT. Mynaric is due to deliver its Condor Mark III terminals early next year. John Eterno, general manager at Loft Federal, says the Condor Mark III terminals enable them to deliver fast and simple operations on orbit. And now to a story that feels a little bit like it comes out of the Jodie Foster movie Contact. Researchers say that known sources of fast radio burst signals from space have doubled over the last few years. Data has allowed scientists to track 25 sources of repeated radio signals and are coming closer to finding out where they're coming from. They say the truth is out there, although that's more X-Files, but it's okay. You can read more about that story and others at our selected reading section of our website at space.n2k.com. And a bit of a random question for you. What were you doing when you were 19? In college? Traveling the world? Maybe hand building a cubesat to inspire future generations? No? Well, that's what a 19-year-old from Australia has just succeeded in doing. Robinson Aerospace founder Edward Robinson released a flat-pack cube satellite kit known as our RASC Cube with an aim to inspire students. The immersive learning experience mimics the look and feel of a real CubeSat and comes with a suite of online teaching resources and plans. Who says teenagers don't provide positive contributions to society? And staying in Australia, Monash University recently opened the National Indigenous Space Academy with an aim to send First Nations STEM students from across Australia to intern at NASA's Jet Propulsion Lab in the U.S. And Monash University just so happens to be competing this year in the world's largest intercollegiate rocket engineering competition, the Spaceport America Cup. Stay with us for my conversation with T-Minus space producer Alice Carruth with more details on that competition. And that's it for today's Intel Briefing. And hey, T-Minus crew, if you find this podcast useful, do us a favor and share a 5-star rating and a short review in your favorite podcast app. It'll help other space professionals like you find the show and join the T-Minus crew. Thank you, and we really appreciate it. Coming up next, all about the Spaceport America Cup. And with me now is T-Minus show producer Alice Carruth talking to me about the Spaceport America Cup. So Alice, could you tell me a little bit more about what the Spaceport America Cup is?
The Spaceport America Cup is the world's largest intercollegiate rocket engineering competition. It's the largest of all of the international meets for rocket engineering. So they have a whole week of competition in person in New Mexico every June, where these students come out with their rockets that they've built over the course of 12 months. They've had to submit white papers in advance that have gone through procedures with the judges. And then on the first day of the competition, they put those rockets on display in the Las Cruces Convention Center, and the judges get to take a really good in-depth look at them to see if the safety procedures and everything have been followed to a T. And then they get their launch card. And then over a course of 3.5 days, they get to go out to Spaceport America and launch their rockets. And this competition is really quite unique. It's not about how high or how fast you can get your rocket. It's about how accurate you are when it comes to your design, build, launch, and recovery. So if you say you're going to reach an altitude of 9,900 feet, it's how close you come within that spectrum. And then it's about how much data recovery they've got. Now, they add extra things in there like payload challenges. So often these rockets will carry payloads like drones to 10,000 and 30,000 feet. And again, it's about how well that payload goes and what they learn from that competition. So this year is being mainly sponsored by Blue Origin, but Sierra Space will be there, Virgin Galactic will be there, Raytheon, Honeywell, and a whole plethora of really great aerospace industry sponsors because they use this competition to recruit from. Imagine getting the best of engineers from across the US, Canada, literally around the world. I think our furthest afield competition students this year are coming from Malaysia, Thailand, Australia. They've got students coming in across Europe, Brazil. This really is a fully international competition. I think there's about 140 teams that will be coming and descending to New Mexico for that week in June. And T-Minus Space is really excited to be able to sponsor it this year. So we're going to be covering this competition leading up to. We're going to talk to some of the participants, those that organise it, and see really what this is about and why it's so important to the aerospace industry to know a little bit more about the Spaceport America Cup.
Alice, and I know this is an event that's very near and dear to your heart, and you've been involved with it for quite a long time. Can you tell us a little bit about that?
Sure. I actually started with the Spaceport America Cup as a volunteer back in 2018 and was working for one of the sponsors at that point. And then the last 3 years, I worked at Spaceport America. So I was involved in this competition when it was a virtual competition in 2021, and then when it returned to in-person in 2022. And it's really quite an emotional competition. We talk very much in this aerospace industry about the importance of workforce development. You cannot get real hands-on experience in the aerospace industry in a classroom. To be able to build a rocket and see it launch and often fail is quite a unique experience. And I say fail with really loose terms because failure is not really a thing in aerospace. It's just an opportunity for you to learn and develop. So a lot of these student rockets don't necessarily go to plan, but it's really an opportunity to see how the students deal with that failure and how they learn from it, how they recover, how they deal with the information that they recover and figure out what went wrong. I was stood next to Purdue in 2022 when they launched and had a CATO, a catastrophe after takeoff. And they were very devastated instantly and disappointed after building this rocket for a year, but very quickly figured out that it wasn't their problem. They had a commercial off-the-shelf engine, and that had an anomaly involved in it. And so to learn from that and say it wasn't necessarily the student's issue, but they learned from the fact that it was a COTS issue that just happened to go not in their favor, was an incredible thing to see them figure out that situation and realize that actually not everything goes your way. And how they recovered that and how they dealt with that data is really important.
I was going to ask, for lack of a better term, what are the vibes like at this? I mean, are people super tense? Is it more like a party, like everyone's excited, or does it really vary depending on how competitive people are feeling that year?
Absolutely. All of the above. I compare this to the NCAA equivalent in academia. This is a real big competition. The students know that there is a lot riding on this competition for them. They use it as an opportunity to be recruited by these sponsors, but they also use it on their resume throughout their lives to say, look, I've been part of this. This is something that I'm really proud of. And it's a bit of a fun vibe. I walked into the restrooms in 2022 and there was the team from Mexico and the team from Poland, and they were swapping sombreros and taking selfies in the mirror. And I thought, what a fantastic thing to witness.
That's so
What a great way for them to meet like-minded students from across the world and exchange culture as much as they're exchanging their ideas in engineering. And that makes it a bit of a party vibe when you see them all cheering each other on. And they really do. They support each other. And that's what I think is really great. It's the camaraderie of it, because there is a competition, but everybody wants everyone else to succeed. And like I say, it's not always about who gets the fastest, who gets the highest. And they do different categories. So you get the commercial off-the-shelf 10K, so going up to 10,000 feet, or you get the SRAD, which is the scientific research payload. So they basically have built their own engines to be able to go on it. So they go to a 10,000 feet category as well. And then they go up to 30,000 feet as well. So you get commercial off the shelf and again, the SRAD. And then they have the different types of fuels. So we get the solid fuel rockets, which are obviously a bit more like your 4th of July rocketry, a bit more reliable. But then you get those that use hybrids, which is definitely an interesting one. And as we know from the aerospace industry, is a lot less predictable. They carry a lot more weight to them when they deal with the hybrids or when they deal with their own design engines compared to the commercial off the shelf. So it's interesting to see the difference. And some of them have regional competitions within the competition. So in New Mexico, there is the Chili Cup between all the different regional universities.
Love that.
And we're encouraging that across the world, so that every single area has their own little mini competition within it, because it's just adds an extra element of fun, because you might not necessarily win, but you might win in your region, and that's just as important to be able to see. And honestly, they're all winners to me. I have not met one student that I haven't been impressed with. They work so hard on these rockets, and they really put so much effort into it. And I have seen so many tears. And as somebody who's been involved as a volunteer and working for the spaceport launch facility, you can't help but get absolutely pulled into the emotions when it comes to a rocket launch. Everybody knows how exciting it is when we see a launch. We saw it with SpaceX when they launched their Starship the other week, how many people were cheering. It's exactly the same when you're watching a rocket launch for a student level competition. People just get pulled into that emotion. So it's exciting that T- is going to be able to capture that this year.
I'm so excited for that. And so tell me a little bit about the success. I mean, success can be a lot of different things. But after the Cup happens and people are hoping to be recruited, so do you have any stories about people who've made a career out of this and starting from the Cup?
In 2022, it was the first time I think we really saw a massive return of rocketeers that have now been recruited and are working in the aerospace industry. So I met people that work for Virgin Galactic, Blue Origin, Honeywell, Raytheon, that started off their career at the Spaceport America Cup and were recruited either directly at the competition or recruited later on. When those companies had seen on their resume that they'd been a rocketeer and participant in this competition, it put their resume to the top because they know how much effort it takes to work on that. And like I say, you can't get that kind of experience in a classroom anywhere in the world. And if you speak to anyone in the aerospace industry, they'll say that they have to start from scratch when it comes to a lot of students that they recruit. And that's a difficult thing to do because what you're learning in the classroom doesn't always apply to the rockets because there's so much bespoke work that goes into every single vehicle that you have to teach them from scratch, whatever happens. But the fact that they've worked on a rocket does give them that competitive advantage when it comes to recruitment.
Theoretical versus practical knowledge is it's a big thing. Absolutely, yeah.
It's exciting to see that those students have then done so well. And I had so many students come up to me in 2022 and say, oh, it's exciting. I've just met somebody who works at Blue Origin and he told me he got recruited at this competition in 2018 and now he's come back with the recruiter and he's recruiting us. And I think that's an exciting thing for the students to really recognize. And that's why the Global Spaceport Alliance have run a workshop series ahead of this competition to really prepare the students for resume building and how to put themselves forward in an interview.
Well, Alice, I'm jazzed about this now, hearing your enthusiasm for it. I can't wait to see what happens this year, and we're so excited to be being a part of the event this year as well. So thank you so much for walking me through it and telling me all about the Spaceport America Cup.
You're welcome. And if anybody wants to hear a bit more details about those that are competing in the competition, they should go to soundingrocket.org. That's the Experimenting Sounding Rocket Association's website, or spaceportamericacup.com, and they'll have details of all those competing. And tickets are on sale now.
That's awesome. Thank you so much, Alice. I appreciate it. And we'll be right back. Welcome back. We sort of touched on the hunt for other life forms in the universe earlier in the program when we were discussing radio signals picked up from deep space. But another indicator of possible presence of life is water. In another mind-blowing discovery in science research, the James Webb Space Telescope has picked up traces of water vapor near another exoplanet. Did you know that the telescope, with its beautiful 18 hexagonal mirrors, can analyze atmospheres from different worlds? Yes, indeed. The James Webb Space Telescope can make some gorgeous pictures, of course, but Webb also has a whole bunch of spectrographic instruments aboard, like the NIRSpec and MIRI, and they can perform spectroscopy at quite a distance, telling us what distant worlds are made of and if they could, perhaps, just maybe, support conditions for life. So water vapor on a distant rocky planet could, in theory, be good news on that front. But before you start to consider abandoning Spaceship Earth and heading off to that planet elegantly known as GJ486b, just know that the super-Earth planet is so close to its host star that surface temperatures are a scorching 800 degrees Fahrenheit. I don't think SPF 50 sunscreen would quite cut it. And that's it for T-Minus for May 3rd, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. And we'd love to know what you think of our podcast. You can always email us at space@n2k.com or submit the survey in our show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in this rapidly changing space industry. N2K's strategic workforce intelligence optimizes the value of your biggest investment, your people. We made you smarter about your team while making your team smarter. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazis. See you tomorrow.